Welcome everyone to today's webinar, Measuring the Value of SPC. My name is Tracy Tartarian. I'm DataNet's Marketing Director and the producer of today's session. The goal of today's presentation is for you, the quality professional, to identify new methods to capture and quantify the monetary value that SPC can bring to your organization. Hopefully this will assist you in justifying your current program or help you win support for a new one. The session today should last about 30 minutes, and we're going to follow it up with a Q&A period. Our presenters today are Brad Armstrong and Frank Tappan. Brad is DataNet's Vice President of Sales. He has 13 years of experience working with manufacturing quality executives to apply real-time SPC software. He offers a significant amount of experience in consulting with these executives on how to improve their product quality, increase customer satisfaction, and grow their manufacturing profitability. Frank Tappan, our second presenter, is the Vice President of Solution Delivery at DataNet. He has over 20 years of experience in implementing quality control software in various industries like automotive, aerospace, medical device manufacturing, plastics, food and beverage, pharmaceuticals, and more. He is a Six Sigma Black Belt and certified quality engineer. So now I'm going to turn it over to Brad and Frank.
Thanks, Tracy, and thanks to all of you for joining us here today. We're going to start the discussion by reviewing the impact of SPC in the manufacturing industry. I don't know if everything we're going to talk about today applies to all of you, but we hope to make this a productive discussion and hopefully give you some ideas to help you on your path. We talk to companies every day that are dealing with new challenges in quality. Maybe you're joining us here because you're frustrated with your current SPC methods and the time you spend managing those activities. Or maybe you're doing SPC for some time, but it's after the fact, and you know there's some quality problems that result from that. Or maybe the case is that you've been pushing for a new real-time SPC program, but you get resistance from management in making the investment. In fact, we've been hearing for years that companies are often pursuing SPC because they think it's the right thing to do, which maybe it is, but they still have a hard time selling the project to management to really get dollars to spend on the project. It's an unfortunate viewpoint in many companies that quality is often viewed as a cost in the company or as overhead, a burden to the business, instead of a cost center where they can find tangible savings. And with any project, it's a good idea to win top-down support and to track the project's success over time to make sure all the initial objectives are met and not just another project of the day. A really great part of our jobs is going out and meeting with hundreds of manufacturing companies every year to see how they've applied SPC methods, from semiconductor to small machine shops and medical device companies and motorcycle manufacturers. Here are some of the common reasons that we often hear about why they've implemented SPC, all of which tie back to variation in their process, like reducing their costs in manufacturing, reducing defects and scrap, improving their yields. In fact, there was a good article on the history of SPC where it talked about how Edward Deming had met with Japanese executives in the 1950s, and his mantra in presenting it to them was that SPC would help them improve quality while reducing their expenses and increasing their productivity and market share. That focus hasn't changed, and a lot of those same results can be achieved immediately by reducing variation in their process. The table here defines performance at best-in-class manufacturers. These are things they're measuring and tracking on a regular basis. For example, 99% of their products are made in compliance. Just to give you an example, a Six Sigma program, companies can expect to see about 99.997% of their products made in spec. That's only 3.4 defects per million opportunities. Pretty good achievement. Still, a common challenge for many companies is justifying and identifying the costs in their quality program. Listed on the bottom row here are 4 common measures, the standard cost of quality measures, and it's pretty widely known that many companies spend their time working with internal and external failures and the appraisal costs. While in practice, if they'd implemented a more preventative model, they can minimize those internal and external failures, possibly eliminate them, and minimize the amount of time they spend in their appraisal activities. In fact, this study by Aberdeen talked about how companies were able to achieve a higher level of quality while simultaneously investing less in their quality programs. With that in mind, this is our hierarchy or a pyramid of SPC enablement within manufacturing. And at the bottom level here, you can see many companies start by doing quality inspection. They're testing their products maybe in the final inspection area before they ship, and they're making decisions based on in or out of spec results. Obviously, defects found here are very expensive. The next stage is maybe a basic SPC program where they're doing SPC on paper, or maybe they take those results eventually and enter them to Excel or Minitab or an analytical software like that, which is great stuff, but it only gives you a view in the rear view mirror. The third stage, real-time SPC, is where companies are empowering their operators to control the process. They're preventing defects before they occur. They minimize variation. Indeed, they have a capable process. And the top level of SPC enablement, looking at the best in class, is where companies are using SPC for continuous improvement. They're striving towards zero defects. They've standardized their processes. Many companies in this range are looking at both product data and process inspection parameters, where they're looking at the key inputs and outputs from their process, correlating the two to make improvement decisions. Indeed, at this level, they've achieved a higher level of quality while reducing their costs of quality. We're going to open up a poll to the group here to get your input on where you see your business in terms of SPC enablement, stages 1 through 4. You'll see in the bottom right-hand corner of your screen an area where you can select an answer, and then we're going to publish those results here shortly for everyone to see where they might stand. We don't share this information. This is just for today's session. And we'll give you a few moments to provide your responses. Okay, it looks like all the answers are in. We're going to run a quick tally on that. Enter in the results. Looks like we've got 100% participation. Thanks, everyone. Okay. Is it all set?
All set.
Okay. Well, as you can see here, many companies have identified that they're within maybe the bottom or the bottom two rings. Over 80% of you had responded that you're doing more quality inspection or basic SPC, with some of you that are doing real-time SPC. We're going to use this information to help guide the rest of the presentation. I'm going to introduce now Frank Tappan. He's going to walk you through the next section of the meeting to help you identify how quality can help pay you back in your company instead of being a cost to the business. Frank?
Thanks, Brad. Welcome, everybody. I just wanted to start by saying thanks for attending today's webinar. I'm going to step you through making a case for real-time SPC, and in particular, I want to start by focusing on several key things that I hope you take from this presentation, in particular starting with common cost. I'm going to go through a scenario where we identify some very simple, straightforward common costs that all manufacturers have. I'm going to then introduce you to some very basic quality and SPC concepts, which you should be doing if you're not. And using these concepts, I'm going to demonstrate how we can translate your defects, your scrap, some of your statistics into cost savings. And we're going to document those cost savings using an ROI worksheet or template that we've put together in Excel, which I'll be sharing with you a little bit later. The goal is to organize your costs in such a manner that you can then present them to upper management, hopefully to get a project approved or to demonstrate the value of doing SPC. A little bit later, if you guys like, you're welcome to contact Tracy or any one of us after the webinar. We'll be happy to share with you not only the PowerPoint, but the ROI worksheet that we're working with. To start with, to the common costs that many companies see can be put into several categories. In particular, the three that we're going to focus on are internal costs, external costs, and an inspection appraisal. Internal costs are costs associated with scrap or rework or things that you identify in the manufacturing of your process. External costs are costs that are incurred after you've shipped the product to your customer. In particular, might be warranty claims, might be product recalls, you might have regulatory fines, say if you're in the food and beverage industry, and usually those are a little bit more expensive. And the third area is inspection or appraisal costs, which you can loosely put that into productivity bucket. What I'm getting at here is how long does it take you to gather the information, to track the data that you have to track to generate the reports. How much time are you spending doing that? And I'm going to demonstrate how by automating the process we can improve your productivity. Let's start with internal costs. And before I get into great detail about the statistics behind this, I want to introduce you to some very basic SPC concepts. When it comes to tracking internal costs, you're either going to be tracking defects, the number of scrap or bad parts that you produce, and or you're going to be monitoring certain key characteristics or dimensions. And in the monitoring of those particular dimensions, you're looking at variation. Now, I just want to start out by saying that every process has variation. Your goal is to reduce that variation as much as you can. And if you look at the histogram here to the right, here's an example of a very standard normal distribution. The bulk of my data is stacking up on the target, but as my data or my distribution drifts towards my upper and lower spec limits, you'll see that I have some parts that are out of spec. In those particular instances, I've incurred the cost. I've either scrapped my parts or I have to do some rework to bring those back into spec. The U-shaped curve that you see superimposed on that is a curve of your costs. As I move further away from my target, the larger my cost gets. The purpose or goal of real-time SPC is to reduce or eliminate as much variation as I can to bring my data all within spec, which will prevent any type of scrap or rework or overfill and increase my yields overall. If you can make a perfect part every time and never be out of spec, how much money would that save you? Well, that's the type of question that statistics can answer for you. And to throw out a few common statistics that will help drive this point home, I'm going to start by just introducing you to CPK, PPM. CPK is the capability index, or how capable is your process at maintaining or holding the spec limits that you've set for yourself. CP is a slight variation of CPK. It's saying if your target is, or I'm sorry, if your process is directly centered on target, what would your CPK be? And PPM is parts per million. How many defects is your process generating should you make 1 million parts at a time? Some numbers to throw at you just to kind of give you some comparisons. A CPK of 1.0 is roughly 2,700 parts per million. In today's industry or in today's environment, most people are targeting a CPK of 1.33 or higher. A CPK of 1.30 is 96 parts per million. I'm going to use a water bottling company for today's example as a backdrop, and I'm going to step through some fictional scenarios where we're going to identify some common costs within this plant. We're going to then step through, take a look at the data that they've been collecting, and generate an ROI from all of this. In this particular example, I'm going to start by just pretending that I've got a bottling operation and I'm measuring certain dimensions. And those dimensions impact the bottle itself. So if you can imagine, I extrude or blow mold a plastic bottle and I measure the thickness of the walls. And if the walls are too thick, I'll have defects. I'll have pinholes or bubbles within my bottle. If those walls are if they're too thin, if my walls are too thick, I'll be giving away product. I'll be giving away plastic. So using that as an example, let me introduce you to the ROI worksheet. And this is something that we've put together in Excel. I'm going to go through these tabs. We've grouped them into different sections. And there's a little introduction section that just kind of explains the basics of this particular worksheet. I'm going to jump to internal failure costs, and in particular the internal failure percentages. If you recall, I was briefly mentioning that one way to track internal failures is simply to count the number of defects that you see. And you can categorize those defects in such a manner, rank them, find out what's the most frequent defect, maybe re-rank them, and find out what's your most costly defect. An example of the bottling operation. I've got a 20-ounce bottle, and I'm tracking some some defects that I see in the plastic or in the bottle itself, bubbles, cap placement, label placement, etc. I've assigned an associated cost. So every time I see a bubble within one of my bottles, it costs me roughly 1.5 cents. And in this particular operation, I produce or manufacture roughly 75 bottles a month. But out of that overall production, a little over 2 million of them are defective or I have to scrap because of bubbles. My current monthly cost is roughly $40,000 for that particular defect. SPC, on average, can reduce the amount of variation by, it could vary from anywhere from 10 to 15% up to maybe 50 or 75%. We've, from our experience, have seen customers reduce their variation on average roughly 25% when it comes to trying to reduce defects. Based on that percentage, I have a projected failure cost and a projected savings from my efforts. And in this particular case, I have a grand total of $54,000 projected savings for the month. Also related to internal failure costs is reducing the variation. So if you measure physical dimensions, weight, thickness, height, diameter, etc., on your products, you'll be able to plot those on a control chart and generate certain statistics, in particular CPK. Many of our customers are targeting a CPK of 1.33 or better. What you can do is take the results of your data, plug that into this ROI spreadsheet with your current CPK, and it will tell you, based on that number, how capable your process is and how many bad products, out-of-spec products, your process will make. In this particular example, I'm making 75 million bottles a month. My average unit cost is, again, 1.5 cents per bottle, and I'm measuring the empty weight, the weight of the plastic. My current CPK is 0.9, which is not great, but it's not very bad. And my target is 1.33. My current failure cost, based on my current CPK, is $7,800. My projected cost, if I make the necessary improvements in my process to drive that CPK up to 1.33, is $74 with a grand savings for that particular defects of $7,700 and change. Again, I go through the process, identify all of my variables, their individual CPKs, and I total up the grand savings for the month, which is $112,000 in this particular example. That's one example of just stepping through variation. The second common cost are external costs. External costs are costs that occur once the product has been shipped. It's already been sent to the customer. They've identified some defects on site. Maybe they ship that back and you incur some travel costs or transportation costs. Maybe you have warranty claims. In either case, usually it's a little bit more costly once to identify a defect in your product once it leaves your facility. To give you some examples that are very common in our customer base, any type of regulatory standards. You have to meet certain requirements either imposed on you by the FDA, where if you're underweight, say in the bottling industry or in the food and beverage industry, you'll incur certain fines. Any type of recall. I think a lot of you are very familiar with some of the recalls going on today, especially the peanut recall, which is very prominent in the news. It looks like that facility in that plant actually might declare bankruptcy. So these particular costs can be very extreme in some cases. Litigation, returns, warranty claims, anything that occurs outside of your facility once you've shipped can be labeled as an external cost. All right, let's take a look at how we roll up those external costs in the spreadsheet. I'm going to go to the External Failures tab. And in this particular instance, what we do is we list the different types of external failures that have occurred at our facility within the last 24 months. And what we're trying to do is identify each and every one of them. In some cases, you might group them as averages. If you have on average, if you have, say, a dozen different fines or returns in the course of 24 months, you might calculate an average. But to get a more accurate cost structure, we want to note each and every one. In the case of real-time SPC, we can actually target 100% prevention or reduction in these costs. If you were monitoring the appropriate dimensions or key characteristics of your product or your process, you would have detected these problems before they left the plant. Now, those would have been internal costs, but my point here is that as an external failure or an external cost, we're going to save 100% of whatever those costs were in the past. So by avoiding those, in this particular example, I have a grand total of $6,396 just by avoiding the cost that I incur in my bottling plant. The third area of common costs are inspection and appraisal costs. There's a certain level of cost that comes from simply having to do the testing, having to check the characteristics using whatever equipment you have, record those results, and then generate control charts and reports and statistics. If you're in a paper and pencil-based system, you're probably spending an enormous amount of time just doing that particular activity. That time could be spent doing other things more productive, maybe monitoring your equipment or doing other work that increase the yield and the throughput of your facility. And the question that I have for all of you is, where are you spending your time? Are you focusing on data collection? Are you focusing on gathering that information? Is it taking hours and hours or days a week to do that? Is your time being spent on production changeovers or reworking the parts that are out of spec? What we need to do is identify each area that you're spending time, and through automation, we're going to reduce that amount of time and increase your productivity. Jumping back over to the Excel spreadsheet again, I'm going to go to the appraisal and prevention costs. And again, just like before, what we do is list each and every task that we have we're spending an enormous amount of time on. Some very straightforward, very common ones would be inspection type activities. And in this particular case, my bottle fabrication inspection area, I'm spending roughly 80 hours a month gathering the information. My individual inspectors have an hourly wage of $15, which translates to roughly a $1,200 cost per month. The projected savings is I'm going to reduce that amount of time I'm spending on an inspection by automating their activities to 20 hours a month, giving me a monthly cost of $300 and a projected savings of $900 for that particular activity. Likewise, we go down all of these individual items, we tally up the total costs and projected savings, and in this case we get a grand total of almost $6,500 a month. The last step in all of this, which we've been doing at every step along the way here, is putting it all together. You want to capture all of these savings and costs in a format, in this case the ROI worksheet that you've been taking a look at, and you want to roll them up or summarize them in such a manner that you can then present them to upper management. What's crucial here is that you identify not only the source of your costs, but the savings and the projected ROI in not only dollar amounts, but time. And to give you an example of that, I'm going to jump to the last couple of tabs in our spreadsheet. The first one being the real-time SPC costs. And what we're doing here is we're identifying all of the costs that are involved in implementing a real-time SPC system. So you want to show that you've done your homework here. You want to identify how much am I going to have to outlay for software? Am I going to have to buy new PCs? Am I going to have to upgrade my devices or gauges and equipment? You want to identify each and every one of those activities, including time. There's going to be some training required. There's going to be some people's time to actually roll it out and implement the system throughout the organization. And in this particular case, we've gone through, identified the individual costs for this fictional plant. And we've got a grand total, well, it's going to be roughly $47,000 or $48,000. We'll say $50,000 is our grand total. In addition to that, we've also identified ongoing annual costs that are going to happen every year. And there's not too many, but in this case, any annual maintenance fee that you might pay for software you produce or purchase. Any additional training, there's always retraining that occurs from time to time. Those are examples of ongoing costs that you want to just show that you've identified what those might be. You then take all of your cost savings and all of the implementation costs and you roll them up into a summary. Now here, what I've got on this particular tab are the totals from all of the previous tabs, and I've grouped them by my current monthly costs, and I rolled it up to look at it on an annual basis as well. My projected monthly and annual costs, so this is after I've implemented SPC, what my cost will be. And then my projected monthly and annual savings. And by doing it in this fashion, not only those little itty-bitty costs that you saw before, $6,000, $5,000, they total up very quickly. And in fact, in this example, I have a grand total of an annual savings of a little over $2 million. It's going to take me roughly 4 months to implement the system and get everybody on board and using it and trained. And once it's implemented, it's going to take me, well, in this case, 0.3 months before I see a return on my investment, before I get any type of payback. Well, this is obviously a no-brainer. If this was my actual plant, this was my actual project for approval, this would get my rubber stamp immediately. Usually people are looking for a time to recover in about a year, maybe a year and a half. That is the exercise that you all should go through. You should identify your costs. You should put them into an ROI worksheet similar to what I've got here, and you should identify if is an SPC or a real-time SPC project beneficial for you or not. You need to assess, is there value in moving forward or not? And I think if you start identifying your costs, you'll find that very quickly the answer is going to be yes.
Thanks, Frank, and appreciate all the ideas as we went through this. Just to summarize a few key points that I think we've emphasized today, SPC is a lot more than just the right thing to do. In today's environment, it can help you be more competitive and more profitable. That SPC programs can effectively be measured, and we've tried to identify some of those key areas today. And obviously, when you need to go and ask for an investment in projects like this, it does help to build a business case and use a worksheet or some type of ROI formula in generating those type of results. We've got a couple ideas of next action or next steps where you could proceed. Of course, we're all available to you. If you have any questions, feel free to email or call us. We also offer online web demos if you'd like to see something like this, or even of our WinSPC real-time SPC program, an interactive demo using your own data and walking through some examples. We also have a variety of articles and white papers on our website, also a free newsletter you could sign up for to get regular updates. So thank you, everyone. We appreciate your input here and for spending your time with us, and look forward to the next time.
Thank you, Brad. And thank you, everybody, for attending today's webinar, Measuring the Value of SPC. This concludes the presentation portion of the webinar, and we'll be opening it up now for Q&A. Again, thank you.